Hello and welcome to part one of Momentum Questions by Mr. Pinder. This is aimed at the Notre Dame students who asked for questions from me. You should already have received the questions in an email, but just in case I've included the question as part of the comment section. Any problems, just email me as usual. Hopefully this will be a bit more informative than just a written answer or a photograph of a whiteboard with a working. So, first question says that two objects, object A and object B, are going to collide. Object A has a mass of 5 kilograms, a velocity of 5 meters per second. Object B has a mass of 9 kilograms and is at rest. A really good idea for all these questions is to have a diagram. This allows us to see what we've got and where we're going. So we start off by drawing a diagram of A and B, point masses, so they're just circles. A, as we've just said, has a mass of 5 kilograms. B has a mass of 9 kilograms. M has an initial velocity of 5 meters per second. Now, a velocity we usually represent with a V. But if it's an initial velocity, we represent it with a U. So I'll be saying that U equals 5 meters per second. And if it's at rest, initial velocity, or U, equals 0. Now, the first thing we need to do is carry on and see where we're going. So I like to finish off these diagrams. I like to see what we're going to end up with. So, little arrow to show after the collision takes place, not a smiley face. And we continue with the question. If there is a 100% transfer of momentum and the objects remain their initial mass, calculate the momentum of object B after the collision. Now, that is actually a small mistake. That should be calculate the velocity of object B after the collision. I will hopefully have made that correction before it's gone into the comments. So, we finish off the diagram. A and B. They keep their original masses. So, mass of A is still 5 kilograms. Mass of B is still 9 kilograms. We've got 100% transfer of momentum, which means that A no longer has any momentum. Its momentum is 0, so it has a mass and momentum is 0. Velocity must be 0. This is a final velocity or a current velocity, so we represent it with the letter V. 0 meters per second. And object B has a velocity, which we don't know yet, so we'll represent that by V subscript B. So we're going to continue with this. Now I'm going to erase the bottom of the diagram just so I've got room to work. But it will be always a good idea for you to actually keep hold of it. So, in these questions we're always going to be using P equals mv, the equation for momentum, where m is mass and v is velocity. Now, we need to find out the sum initial momentum. So the total momentum before the collision. So we represent that with capital sigma, which is sum of momentums in the initial situation, sum initial momentum. Now that will be equal to the initial momentum of A plus the initial momentum of B. So that will be M-A-U-A. Remember, initial velocities are represented by the letter U. Plus MBUB. So let's get calculating. That's going to be 5 times 5 plus 9 times 0. Now if we've got anything times 0, we know it's going to be 0, so we can cross it out immediately and ignore it. So that will be equal to 5 times 5, which is 25 kilogram meters per second. Always remember your units. Now the next thing we need to remember is the actual conservation of momentum. The conservation of momentum states that whatever the momentum is before a collision, the momentum after the collision will also be, assuming that no external forces apply. We're always going to assume there's no external forces apply, but it would be useful to remember that because in some questions you could be asked to state that assumption. So, if this is true, the sum of the initial momentums must always equal the sum of the final momentums. Therefore, the sum of final momentums must also be equal to 25 kilogram meters per second. And that's part 2. Now, again, I've started to run out of space. These boards are quite small. So I'm going to flip the board over and we can continue. Just remember that our sum of final momentum from what we've just calculated is equal to 25 kilogram meters per second. Make sure we know that. So, now we're going to calculate the final velocity of object B, or B's velocity after the collision. So, we have sum of final momentums. It's still a sum of momentums, except it's the final momentum, so it's the final velocities this time. So, it's going to be the mass of A times the final velocity of A, plus the mass of B times the final velocity of B. Now, usually in physics, we like to rearrange first and then put numbers in later. But this is one of those rare opportunities where I personally prefer to stick the numbers in first. This allows us to see some little bits and pieces which make our life just a little bit easier. So we have 25 equals ma, which if we remember is 5 kilograms, times velocity of A, which if we remember is 0 because of the 100% transfer of momentum, plus the mass of B, which is 9 kilograms, times VB, which we don't know yet. 5 times 0 is 0. Cancel that out, saves us a bit of a problem later on. So 25 equals 9 VB. A very simple rearrangement, that VB must therefore equal 25 divided by 9, which, if you put that into a calculator, you should have 2.8 meters per second. And that's it. The answer is 2.8 meters per second. Join us for part 2, and we will go through question 2 out of 5. Thank you very much. Please leave positive comments. This is my first video.